Hi, pre-calculus students. It's Ms. Culver. Welcome to our semester of pre-calculus class and welcome to my living room for your notes. This is pre-calculus. I'll usually put a PC to abbreviate 1.1, rectangular coordinates. Just so you know, note packets are rare. I know you're used to that in Algebra 2B, but pre-calculus is very much a college level course where you would be used to taking notes, and so we'll do them that way. So we do our notes through video, but I'd also like to take this moment just to welcome you and to let you know that I'm happy to help you with anything that you need, and that as I put in my first update to you, please do not freak out. Okay. Pre-calculus does take a lot, but you know that. You knew that probably when you were taking the class. But my job is to help make it easier for you, not harder. So please understand what you'll be doing is doing notes and examples on video. So please take notes so that you can use those while you're doing your homework. Then you'll do a first attempt on every single problem on the assignment that goes with the video. And then you'll be coming into class and we'll be going over every single problem that you want on these sections before you take any sort of assessment on them. So this is going to take a little bit to get used to. Some of you are at home for the first time today, maybe feeling without some of the things you need, like a graphing calculator. There's many free apps you can download on a phone. I am having you sign up for Delta Math today. There's a calculator on there, but I do understand that it is in addition to doing this, that just getting the hang of what your resources are can be overwhelming. Okay, so we're going to do some examples. I also want to tell you about chapter 1. I put this in my update. Everything in it pretty much is review, but they put a lot into chapter 1, so that also can feel overwhelming, like this is too much. Later on, when we go to learn new things, then it's a little bit more compact, a little nicer. So if you find that pre-calculus goes well for you from the beginning all the way through, good for you. If you find that it's a struggle at the beginning, that's normal. And just please communicate with me, and I'm happy to help you. So let's take a look. Rectangular coordinates. Here's some important formulas that you need. And we may talk about them more in class, like where do they come from and why. Okay, so some important formulas would be the distance formula, which you already know from geometry, right? And the distance between 2 points, if you have a first point x1, y1, and a second point x2, y2, would be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. The midpoint formula would be the point that would be in the middle of two given points. And so it kind of makes sense. Midpoint is a point, so it has an x, y, and you add up the two x's, divide by 2, giving you an average x, and you add up the two y's, divide by 2, giving you an average y. So that also you probably remember from geometry. You probably also remember the Pythagorean theorem, a squared plus b squared equals c squared. That's when you have a right triangle and the legs are a and b and the hypotenuse is c. If you notice, the Pythagorean theorem actually has a lot in common with the distance formula. If you notice, something being squared plus something being squared, but instead of having it equals something being squared, we just took the square root of both sides. So the distance formula actually comes from the Pythagorean theorem. Percent change you did way back in Algebra 1 or Algebra 2A perhaps. Just wanted to make sure it does come up in this section. So percent change would either be an increase or decrease. An increase, of course, if an amount goes up over time. A decrease, of course, if an amount goes down over time. And so it would be the amount of change divided by the original amount as far as time goes, times 100 to make it a percent. By the way, I just noticed now that I'm done with the formulas, I didn't say, so I'm pretty casual at home. So when I'm doing my videos with my dress and everything, so I hope you don't mind and lack of makeup. Anyway, number 2, we're going to do some examples right from your text. So let's talk about that. Either you already have your text because you were in school. If you don't have your text, then notice that on Schoology in your classroom, when you go to materials, I have posted the first sections 1.1 to 1.5 in pre-calculus along with the solutions, so that you can go to that PDF and you can follow along with me and you can do the problems. So the textbook in full is in materials in Schoology. That it's pretty big though, so that can take a lot to pull up. So I also have a separate PDF from just 1.1 to 1.5. Might be easier for you to download. Okay, well, so we are on page in section 1.1. Let's see, we're going to do number 24. That is on page 8, right? And this is the example. And of course, I gave other problems in this section. So here's what it says. Determine the quadrants where x times y is less than 0. So notice I made you a little graph of the coordinates, right? First coordinate, second, third, and fourth. So how do we determine where the coordinates are? Anywhere where, if you drew a point in any coordinate, if you took the x of that coordinate and the y of that coordinate and you multiplied them, you would get a number less than 0, a product less than 0. Notice that would have to be where x is negative and y is positive, or where x is positive and y is negative, right? The only way to get a number less than 0 is where a number is negative, and that would be where you have a negative times a positive, right? So let's find these quadrants. Let's find the quadrant first where x is negative. Okay, that would be in this quadrant 2 and 3, but where y is positive, okay, that would be only in the second quadrant, right? In the second quadrant, x is negative and y is positive, okay? We also need a quadrant where x is positive, that would be 1 or 4, and y is negative, that would be 4. If you take a look, x is positive, y is negative in the fourth quadrant. These are your 2 answers. On B, 46, right? So 46 is on the next page. Show these points form an isosceles triangle. So I took the points that they gave and drew a picture. You don't have to if you're good at using those 3 sets of points. What I just need to show is that 2 sides of this triangle are equal in length to each other. So it doesn't say it, but it sounds to me like I'm going to need, forget my C, the distance formula between the points until I find the two sides that are equal to each other. So let's go ahead and use -2, 7, and 2, 3. Let's go ahead and do that, okay? So I'm going to use the distance formula, okay? x2 minus x1 plus y2 minus y1. Let's see. Here, this is a positive 4. I get 16 here. 16 plus 16. And let's do this again. 4 squared is 16. -4 squared is 16. I have the square root of 32. Okay. Between these two points here, that distance. Okay. I'm going to leave it because if something else is a square root of 32, then I'm good, right? So I don't really need to make it a decimal or reduce it in any way. Let's try between 2, 3, and 4, 9. Okay, that would, let's see, 4 minus 2 squared plus 9 minus 3 squared. Let's take a look. That would be 2 squared is 4, And 6 squared is 36. That is the square root of 40. Okay, so far I do not have an isosceles triangle. Okay, so what I'm going to do, sorry, to save myself some room here, I'm going to hang on to the square root of 32 and the square root of 40. I'm going to find the distance between these 2 points, and hopefully it matches one of those, right? So square root of 32 and the square root of 40 are the lengths of the sides that I have. I'll put that right here. There we go. That's a good spot for it. Okay, let's check the distance between the 2 points on top. 4 minus a negative 2 squared plus 9 minus 7 squared. Let's see, this is going to be 6 squared is 36 plus 4 square root of 40. There we go. We did in fact show that we have an isosceles triangle because these 2 sides are equal to each other. I have a problem like number 76. Okay, and I think I have the closed captioning on. Will it let me, just for the live transcript, just so you can see at the bottom here. I'm just going to turn that off for a second. Okay, and let's take a look at number 76. Maybe if I go down a little bit there. There we go. Now if I put the closed captioning back on. There we go. Let's see. See if you can still see that. Sure. So a problem like number 76, I am pretty sure if you were given 2 points and you were asked to find a midpoint, you could use the midpoint formula to find that. However, what if you were given an endpoint and a midpoint and they wanted the other endpoint? Okay. Now, could we use the formula? That's how the book does it. They make it super complicated, right? But it's actually not complicated at all. Isn't this midpoint in between this endpoint and this one? So let's take a look. The x of the endpoint was at -1 and it went to 2. That means it went up 3. Doesn't that mean for this x to be in the middle of these endpoints that I would also have to add a 3 to get to the other endpoint on the other side of 2, 3. So that would be a 5. Let's take a look at the y's. The y's, it was at 4 on the endpoint and it went down 1 to 3. For this to be the other endpoint and to put the midpoint in the middle, wouldn't I have to go down 1 again and be at 2? So your book does it kind of complicated, but let's check the midpoint formula now. When I check the endpoints, 5 plus -1 is 4, divided by 2 is 2. I do have the midpoint. 2 plus 4 is 6, divided by 2 is 3. There we go. It in fact did work easily. Okay, let's see if I move this over just a little bit so you can see. There we go. All right, percent change. All right. So let's say that gas was originally $3.79 per gallon and it went down to $2.39 per gallon. That is what has happened in the last few years. So the first thing we need to do in our formula is find the actual change, right? So the change was, I'll find the difference between $3.79 between $3.79 and $2.39. And actually, it's almost like having 2 points. I'm going to do this value minus that value. Either way you want to do it, 2.39 minus 3.79 is a -1.4. You could also do $3.79 minus $2.39 and just recognize that it went down, so it must be negative, divided by the original amount, which was $3.79. I can see right here, it started here and then arrowed to that amount. So let's take a look. That is -1.4 divided by 3.79. It's money, but I'm not really seeing it that way, times 100 to make it a decimal. It went down 36.939%. I tend to go to the third place on everything because we do in calculus, and this is called pre-calculus, right? Let's take a look here. Milk went up from 289 to 310. Let's find that change. We know it's going to be positive, right? Because it went up, divided by the original amount, right? You can see by the arrow, it was originally $2.89. So let's see, 310 minus 289 divided by 289, right? And that is a change of 7%. 7.266%. All right, let's take a look. So 31 minus 289, and that was divided by 289. Got it. Okay, now this problem is going to be just a little bit more difficult because it's on the calculator. So just so you know, in section 1.1, in materials in Schoology, I've also posted how to do some things on your TI-84 calculator, or perhaps you have your own calculator and you already know how to do this. If you do not have a TI-84 and you're at home, then you will see you have instructions on how to sign up for Delta Math. And I also gave instructions on how you can use their calculator, okay? This is number 74. Now, what we're gonna do on number 74 in your book is they give the year starting in 1994 through 13 years through 2007 of how many women's and men's college basketball teams there were. So we're not actually going to answer the questions they have in the book because this is like the first time together we're doing this, so I'm keeping it a little simpler. I'm going to use my TI-84, and we're just going to look at the women's data only. We're going to put that data in, and we're going to do a linear regression, just basics, making sure you get the hang of this. We're also going to talk about how you graph it. It's also in materials under the assignment 1.1 in Schoology. Okay, so women's only. So the first thing we're going to do is we are going to input the data, the time, the years into an L1, and the women's data into an L2 on your calculator. Please note when you look in your book that the years are from 1994 to 2007. That is not how we put the time into the calculator, right? Your calculator doesn't know that 1994 is a year. It thinks it's 1,994. So when you have years, days, what we tend to do is input a 0 for the earliest time offered to you, and then a number for the number of years past that. So in an L1 for 1994, we're going to put a 0. And then for every year past that, we're going to add 1. This makes much nicer equations instead of using years that are in the thousands. So the first thing you do on your calculator is stat and edit, right? So there's your stat button, right? So we'll hit stat and edit, right? You're probably used to this, right? And then I put the data into the calculator in an L1 and L2. Hopefully you know how to clear your data, okay? The next thing I'm going to do then is, again, let me show you again how in an L1, how I put the data in instead of 1994, but starting at 0, and it goes through 13. Let me cursor down for you. There we go, through 13. There we go. Okay, so we want a linear regression. So the next thing we do is hit that stat button, and then we're going to move over to calc, and we are going to go down to number 4, linear regression. There we go, and we're just going to hit enter until it gives us the equation of a line we are looking for. There we go. So I'm going to write that right here. We get ax plus b would be 14.338x plus 856.086. I can write that a little nicer, 856. There we go, 0.086. There we go, that's what I got there. Okay, now, or on Delta Math, you can use their calculator. Instructions are in materials 1.1 school. Now, to graph this line or to graph the data, I didn't have room to fit it, but it is in materials. And the first thing we would do is make sure our y equals is clear. There we go. And it is. Our y equals is clear. Now, if we want to plot the statistics that we had in the calculator, we are going to go to second y equals. So second y equals, that is stat plot. We're going to make sure all of our plots are turned off, except for the first one. So I'm going to hit enter. There we go. And I'm going to, on is blinking. I'm going to hit enter. There we go, to make sure that's on. My type is correct. My X list should be L1. My Y list should be L2, and it is. And I make the mark a square or a plus, a little bigger than the dot. Now, the next thing I need, though, is I need to do a zoom stat. So zoom is the top middle button. And I don't want to have to make this window myself, set the X and Y axes. So we're going to go down to number 9, which is zoom stat. There we go. And we're going to hit enter. And that way our calculator will pick up on the stats that we put in L1 and L2. There we go. Doesn't that look nice? So there's the data, and we wrote a linear regression for it. There's more we could do with it, but I think that's enough for today. So I know this video was a little long. I usually try to keep it a little shorter, but I had a little bit more to say on our first time together today. So thanks for hanging out with me. I hope you got the notes. I hope you can see them well, and have a great first day.